Here's the third truss problem that we want to find the reaction force for. I'd say it's in the middle for difficulty. It's a little easier than the first, a little harder than the first one, a little easier than the second one. The roller sitting over here with the wheels, you can see those right away. And when you see the roller with the wheels, you know you're going to get one reaction force. In this case, that one reaction force is going to be a push up at the wheels, so we're going to label that reaction force D in the Y direction. We have our pin over here, reaction force A in the Y direction, and reaction force A in the X direction. Our job now is to find those three reaction forces. Once we find those three, we've stabilized the entire structure and made it static. We're going to come in with the sum of the moments. Sum of the moments must all add up to 0. The 500 pounds of force, 500 pounds of force, that's 5 feet away from the pin. And that's going to make the structure want to spin clockwise, so that's a negative moment. Plus the 1,500 pound force, which is 10 feet away, also want to make it spin in the same clockwise direction. That's a negative moment. So the rulers really need to stop those things from taking effect and making the structure spin clockwise. So in comes RDY, and RDY is working 15 feet away from the pin. Everything is measured from the pin. Based on this, we're going to find out that RDY must come in with 1,170 pounds. Of course, I rounded my answer a little bit, but that's what it needs to do, is push up with 1,170 pounds. That offsets the load that's actually on that structure, 500 pounds and 1,500 pounds. So RDY up 1,170. Some of the forces in the X direction must all add up to equal 0. This will be easy. So if we want to go X direction, the only force that can act in the X direction is RAX. So it's alone, and it can only have 0 pounds of force. Otherwise, the whole structure could move left or move right. Some of the forces in the Y direction must equal 0. Well, right away we knew that there was 500 pounds down. We knew there was 1,500 pounds down. We then learned that there was 1,170 up. And then there's the last thing, which is RAY. There's some help on the other side to help hold this weight up. RAY will hold its share. Together they need to hold up 2,000 pounds. So RAY comes in, and it comes in for 830 pounds of that force. 830 pounds up. So in this problem, once we made sure it wasn't going to have a spin, the whole structure, we had two forces that wanted to see it spinning counterclockwise. So D came in and offset that by pushing up. And it did that by pushing up with 1,170 pounds. There was only one left-right force, so RAX ended up being 0. And last but not least, RAY needed to help out, push up. There was 2,000 pounds pushing down, so it needed to push up with 830 pounds.